My name is Paul Jones. I work for Boehringer Ingelheim. I'm in the IT department. I'm actually a lab scientist. I ran the NMR lab for many years. About 10 years ago, I went over to IT. Shortly after I went over to IT, started working on an initiative which ultimately became allotrope. So we've heard a little bit about allotrope at various points during the conference, and I'd like to give everybody sort of an overview of what allotrope is, what it's trying to do, what its mission is. Okay. And so who is allotrope? So there's really three main components you need to be aware of. So the first component are the member companies. These are biotech and pharma industries, and you can see the list here. The member companies provide the funding, but they also provide the subject matter experts in the techniques, as an example. The second main component is our software partner, Austis, because very early on we recognized that while the pharma companies are great at producing medicines and therapies for people, they're not so good at all times at developing software. So we needed to rely on a professional software partner. So after a very rigorous RFP process, we chose Austis. And the third main component of this is an essential component, which is the vendor community. And you see some names here you recognize, but there may be some that might be maybe a bit of more of a surprise. So for example, we have some universities and we have an art museum. Now why do we have effectively an art museum as part of allotrope? Well, it turns out that as a part of their conservation efforts, they use analytical chemistry to analyze works of art, and so they're interested in using the allotrope ontologies, which I'll talk about a little bit more in a few moments, to characterize the results of experiments that are conducted on works of art. So what are the main objectives of allotrope? So really, this should come as no surprise to anybody in this room. We want to reduce, again, manual effort and paper, enhance scientific reproducibility through increased data integrity, quality and compliance, and preserving the context of an experiment. Likewise, by having a standardized format to simplified IT and systems integration, streamlined access, and forming the foundations of smart data, and to be able to use semantic technologies within organizations. Again, none of this should be a surprise. So what are the components of the allotrope framework? Now, we've heard some talk about, a standardized format, and indeed, that's an important component of what allotrope is trying to deliver, the allotrope data format, or ADF. But the format itself would not have solved all of the problems we have seen on the previous slide, because the format is just that. What you need on top of that is you need structure and you need context for the metadata. And in order to be able to achieve that, we're defining a series of ontologies for the various techniques, broken down into specific domains. And likewise, the ontologies themselves are not sufficient. So for example, in a data integrity scenario, where you want to ensure that all of the terms that are defined in the metadata are related to each other in exactly the same way that is specified, for example, in an SOP, you need to apply relationships to those terms in the ontologies. And so the way to sort of visualize that is, there we go. You can think of the ADF file itself as a graph instance, which is classified via the ontologies. And the ontologies provide a standardized vocabulary to the allotrope data models, which then provides structure to the ADF. So these three interrelated components form the basis of what we're calling the allotrope framework. So it's more than just ontologies and taxonomies. It's more than just data models, and it's more than just the file format. It's all three working together in concert to be able to deliver those objectives we talked about a moment ago. Now, you might ask, well, why build a new format? There's a multitude to choose from. And indeed, there's a quote, unfortunately, you can't read it here. It's from Andrew Tannenbaum, a well-known computer scientist, that says, essentially, the nice thing about standards is that there are so many to choose from. And as you look through the standards landscape, you find that, as we compared those standards to requirements very early on in the development of the project, we found that the majority of the standards, either only partially met or did not meet the requirements. And so the approach from Allotrope from the very beginning has been to reuse existing standards wherever possible, and then to invent only in those cases where an existing standard does not exist. So again, when you think of the Allotrope data format, it really is a federation. For example, the container for the Allotrope data format is built on the HDF5 specification. That's a file format which has been in existence for about 25 years, and it has some very important characteristics that were important for Allotrope. So it's efficient in its storage. It can store very large amounts of information. It's a versatile container, and plus it has the ability to very efficiently handle sparse matrices, for example. And that's particularly important for certain kinds of techniques in which data are acquired in a way that would be amenable to storage in a sparse matrix. Now, talking about the metadata. Okay, you might recognize here's a portion of materials and methods section from a journal article. In the paper world, this is really the gold standard for preserving context. Well, how does this map to what we're trying to do in Allotrope? So as we go through, and I'm just going to sort of build this slide out, it turns out that we can map the terms in pretty much in any standard materials and methods section to terms in the Allotrope taxonomies and ontologies. And indeed, there are other things which are not captured in the experimental procedures that you would find in a paper document that are also accounted for in the Allotrope ontologies. So, for example, things like equipment status, calibration status, some audit trail information, etc. So there are other things that go beyond the paper world that are represented in the Allotrope ontologies and therefore are represented in the Allotrope data files. So again, remember, the concept is that you define the structure for the metadata using the ontologies and the data models, and that's put in the ADF container. So sort of looking at how the governance might work. And so this is just an example. So you have vendors, you have companies. They don't necessarily have to be pharma. You have academia. All of these groups together form a working group and to provide sources of new terms, which would go to the curation team, which is composed of SMEs, a knowledge engineer. Again, you don't want pharma doing this by itself. You really want professionals that understand the science, the knowledge engineering, to be able to develop taxonomies and ontologies which are capable of being scaled and have the proper properties of inheritance and so on and so forth. And then so the idea is that once the curation team has a set of provisional terms, there would be a public review process and ultimately integration and release. Again, it's envisioned as being a very controlled process to ensure that only those high-quality terms are incorporated in the Allotrope taxonomies and ontologies. So reducing it to practice. All of these bullets that you see here, really the important point is adoption and integration by member companies. Okay, Allotrope, it's not a theory. It's not a white paper. It's not a paper specification. It's at the point now where it's actually being adopted and integrated by Allotrope member companies. And I'll talk about what the release roadmap is and give you a sort of a flavor of what these projects are in a little bit. But the important point is this is real, this is now. So this is an example of the various taxonomies which are currently under development. Now, an important caveat I want to get out front just to make sure that everybody is completely aware that the maturity and completeness of these taxonomies are based upon the individual use cases that were used to develop them. Because as I said a moment ago, Allotrope member companies are now working with the framework internally within their companies in integration projects. And as an outcome of those efforts, very often taxonomies and ontologies are being developed as a part of those efforts. So depending upon the scope of the efforts, that there's various maturity. There are three that I would like to call out specifically because they're being very intensely developed right now. It's LC, MS, and NMR. Very quickly, the release roadmap. So there's really three associated products corresponding to the three layers of the diagram I showed before. There's the ADF file specification itself, or the ADF file itself. The first public release is scheduled for mid-year. There's the allotrope foundation ontologies, public release scheduled sometime around third quarter, and the allotrope data models public release scheduled around the end of the year. And I'm going to skip over this, the next slide for time. Key milestones. The key takeaway message from this slide. We started development in 2013. We had our first version in 2015, public release in 2017. Again, a 2-year cadence. You know, this is not an extended project that takes forever to deliver. Allotrope is very focused on learning by doing and delivering. And finally, just as a piece of information, the upcoming workshops that are being held, there's a public component to each one of these workshops. So there will be one in March at Pfizer Groton in Connecticut in the United States. There will be a workshop in June at GSK in Ware, and there will be a workshop in September at Merck in New Jersey in the United States. And finally, I just want to give you just sort of a very high-level overview of some of the integration projects that are going on, just to sort of illustrate the diversity. So on the horizontal axis, we're looking from research to development to commercial. And on the vertical axis, these are various member companies within Allotrope. And you can see in the gray boxes the techniques that are being worked on. And in the yellow boxes is the work process or the workflow which that project is part of. And so there's a number of techniques. So for example, at BI, we're working on NMR, which is actually not listed here, but we're working on NMR in sort of the non-GMP space in the development context, reaching back into research. And thank you very much. Be happy to answer any questions.